Hello everyone. This week we're going to be covering the supply and demand model. It's going to be kind of our main workhorse model for the rest of the course, and so it's really important to get a strong foundation in it moving forward. I'm going to start out by covering a few background definitions before moving on to the theory of supply and theory of demand. Both of these are going to involve a little bit of math, but nothing too extreme. And then finally, I'm going to wrap up by talking about a few topics in market analysis that identify some instances when the theory of supply and demand deviates from reality a bit too much to be useful, and so it's an important aspect of learning the limitations of the model. So, just digging through definitions here. Demand is the willingness and ability of purchasers to buy goods or services. Similarly, supply is the willingness of producers and merchandisers to provide goods and services for sale. Buyers or demanders will want to purchase more of a good if its price declines. I think this kind of makes sense with our intuition. If apples are 50 cents, you're probably going to buy more of them than if they are $1. And, maybe in a different context, an employer's going to hire more workers if the wage rate is lower. And similarly, sellers or suppliers will want to produce more of a good as its price increases, right? So like if you can sell a car for $1,000 more, that supplier will be willing to produce more of those cars for sale. Just a few more definitions. We've got market price. So that's the prevailing price for a specific good or service at a particular time in a given market. We also have market quantity sold, which is the number of units of a specific good or service sold in a market at a given time during a particular period. So our model, the supply and demand model, identifies this market price and market quantity sold as something we call the equilibrium price and quantity, equilibrium price and equilibrium quantity, which we identify with a P star and a Q star. So with that, we should really move on to kind of more formally modeling this. So let's dig into the theory of supply in a bit more detail here. So let's start with an example. Suppose that you run a firm that sells bikes. If the price of bikes falls, so let's say that the price of bikes falls, how is that going to change quantity? So if you think about running a firm, if the price falls, that means that you're going to be making less profit on each unit that you sell. So you might be inclined to produce fewer bikes in the future. So that the implication of that is that as price falls, the quantity that you produce is going to fall. And similarly, if the price of bikes increases, that's going to imply that you should increase the quantity you produce. So this is the positive relationship between quantity supplied and price. Let's take a broad view for a moment and think about a market for bikes in, say, a city. So this is the market where all suppliers are going to be selling bikes at the same time. So we're talking about all suppliers together. And you see in this chart here, we've got that relationship. If the price is $700 per bike, then 300 units will be sold. Produced. If the price is $800, then 400 units will be produced, and so on. And so we can go ahead and graph this on a graph to illustrate this with some sort of curve. So I'm going to go through the full graphing exercise here. I'm not going to do this every time, but especially early on, I think it's important to kind of get to review basic graphing. For the supply and demand model, we always put price on the vertical axis and quantity on the horizontal axis. So if we say, all right, at a price of 700, we supply 300 bikes. So we go ahead and put a little dot there. Price of 800, the supply is 400. Price of, let's go ahead and skip some points. If the price is 1,000, it's 600. $1,200, at a price of 1,200, 800 bikes are produced. So right about there. You can see that this is going to create this linear relationship between those points, and we call that the supply curve. So this isn't very instructive in and of itself. It just tells us how many bikes are going to be produced at each given price. But what if something changes? So usually we're talking about all factors fixed other than price and quantity. But let's suppose that something does change. What if bikes become cheaper to produce? And as a result, suppliers are willing to produce collectively 100 more bikes at every price. So making that alteration to our chart up here, that would be represented as like 400, 500 to there. Just kind of extending those cells downward. So this be 600, 700, 800, 900, not 9,000, 900, 1,000, 1,100, 1,200, and 1,300. So if we go ahead, let's go ahead and graph our original supply curve in on this graph to the right. We can do that with just 2 points because it's linear. So at a price of 700, which is represented by this mark, 300 bikes are produced. And then let's do the far point. At a price of 1,600, 1,200 bikes are produced. That puts us right about there. Draw a straight line between them. And this is our supply curve. And this is... let's call this supply prime. And so whenever we draw this next curve, we'll label it S prime. All right, so let's say price is 700, then 400 bikes are produced. And at a price of, let's do a few points along here, at a price of 1,000, now 700 bikes are produced. Puts us somewhere about here. And then kind of something on the far end of the curve at a price of 1,500, then we can see that 1,200 bikes are produced. So right about there. And we can see that this new supply curve lies to the right and parallel of the first supply curve. So in the background here, let's say that suppose that suppliers are willing to supply 100 more bikes at every price. So the supply curve has shifted outward because these suppliers are willing to supply more. And so we can see that it's shifting out to the right. So this is kind of a more specific graphing version of something we'll do throughout this course, which is here's a market or here's a supply curve. something happens, tell me which direction the curve shifts. And so the curve will either shift outward as it becomes, as suppliers are more willing to supply, or inward as suppliers are less willing to supply at a given price. Whenever we are talking about a curve shifting, a supply curve in this case shifting, that is a change in supply. That is distinct from, for instance, saying we are at this point where 800 is being produced at a price of 1200 and moving along the curve. So if we move along the curve, that's called a change in quantity supplied. If a curve moves, then that's a change in supply. If you move along a curve, that is a change in quantity supplied. And so if price is changing, then we're talking about moving along the curve, and that's a change in quantity supplied. But if some non-price determinant is changing, for instance, cost of production, and a few others we'll go over here in just a moment, that means that supply itself is actually changing, not just the quantity. So here I've broken out supply into, say, 3 different producers of bikes within the same city. And we can graph these individual firm supply curves just like we can graph the market supply curve. So let's go ahead and do that now. All right, so producer 1 isn't willing to produce anything until we're up to around 1300 for the price. So for producer 1 at a price of 1300, they're willing to supply 25 bikes. And at a price of 1400, they're willing to supply 50. So just like a little bit more. 75. Until finally they're at 100 whenever we get to 1600 in price. And so we get this little, and we'll call this supply curve sub 1 to represent that it's producer 1. All right, so let's draw in a supply curve for producer 2. So they, at a price of 700, are willing to supply 50 bikes. Oh. Get the color change there. At a price of, let's go up a bit. At a price of 1,000, they're willing to supply 200. And at a price of 1600, they're willing to supply 500. So it should be thereabouts. So if we connect these with a straight line, more or less, we get supply curve sub 2. And finally graphing the last supply curve, or the last individual producer supply curve. At a price of 700, they're willing to produce 250. Be the largest supplier, and at a price of 1600, they're willing to supply 600 bikes. So connecting these up, we get supply curve 3. And if we were to add up all of these quantities, you'll see that we get the same supply curve we had initially in the first example. And so if you sum up across prices, so here we're saying, all right, if the price is 700, we're then going to sum up all the quantities that each individual firm is willing to produce to that amount, and then that gives us the total market supply. And so it's important to keep these two concepts of individual supply curves and the market supply curve kind of separated. Notice here that each individual producer supply curve is upward sloping, just like in the first example here where the whole market curve is upward sloping. All right, so just going over a few of the non-price determinants of supply, just to give us an idea of how these curves can shift around. All of these are important determinants of essentially the position and the slope of the supply curve. So let me just draw a simple supply curve here. Price on this axis, quantity on this axis, and we know that the supply curve shifts upward because of the positive relationship we established at the beginning of this. Suppose that there's a change in the number of sellers. Let's put a specific example on it. Let's say that there's a reduction in the number of sellers. Thinking back to our earlier examples, if one of the sellers of bikes were to just disappear, which way do you think that this supply curve is going to move? Inward or outward? Well, if there's fewer, imagine we just kind of struck one line from our previous chart where we had 3 different producers, then we're going to produce fewer bikes overall. And so that it would make sense for the supply curve to shift inward. That's prime. That's that example. Some other things that may affect this would be the technology of production, input prices, seller expectations about the future, the price of other related goods and services, and the supply of natural resources. Let's do a couple more of these examples before moving on. Let's talk about the technology of production. So we've got our initial supply curve here. And let's suppose that the technology of production of bikes improves so that we can produce bikes more cheaply. So as a result, we're likely to expect that more bikes are going to be produced. So this supply curve should shift outward. And we're assuming that the technology of production gets better. And here we're assuming that we're getting fewer sellers. And finally, let's do one more. Let's talk about seller expectations about the future. So let's suppose that sellers of bikes get really optimistic about the future. There is a pandemic on, and a lot of people have spare time and they're getting into cycling, which isn't a joke because bike shops are actually incredibly sold out of bikes at the moment. So as a result, they may increase production of bikes and be willing to supply many more bikes to the market. And so these are all different ways that the supply curve can be shifted around by non-price determinants of supply. Let's switch to a different market and think about how these curves would shift around in that scenario. So let's say that we've got a market for lawn mowing services. So let me go ahead and start. So let's consider a few things that could happen in this market. So let's suppose that the price of fuel increases. Would you expect that to cause the supply curve for lawn mowing services to shift inward or outward? So here's our supply curve, price on the vertical axis, quantity on the horizontal axis. So think about that. So fuel is an input of production for lawn mowing services. You got to fuel the lawnmowers with something, right? And so if that price of fuel goes up, then it's going to be more costly to provide that service, so suppliers are going to be less inclined to provide that service. And so as a result, we would have an inward shift of that supply curve. So let's suppose that more people decide to offer those services. So this is an increase in the number of suppliers. So if we start with our normal upward sloping supply curve, which way do you expect that supply curve to shift as a result? So I'm just going to leave that one up to you for now. All right, so let's shift our attention to the theory of demand. Let's put ourselves in a situation kind of analogous as we did in the supply scenario. Let's suppose that the price of bikes falls. Are you likely to purchase more bikes or fewer bikes as a result? Well, if the price declines, then that means that it's going to be relatively easier to purchase a bike. And you have to give up fewer other things in order to do it. And so you would likely be inclined to purchase more bikes as a result. If you don't have a bike, you might purchase one, or if you have one, you might get an additional bike. And similarly, if the price increases, then quantity demanded is likely to decline as a result. And so this is just the intuition of how demand functions. And just like with supply, we can represent this with a sort of graph. So if we start at a price of 200, we see that demand is 1,000. So putting us somewhere out here. And let's do a middle point. So if the price is 1,100, then we can see the demand's about 700. And finally, if the price is 2,300, we see that the quantity demanded is about 300. So 2,300 is about there. So we can put all of these points on a straight line. There, it's a little bit off just because of my inaccurate scaling on here. But regardless, gives us this demand curve. And it's downward sloping because of the intuition we talked about at the beginning of this section, right? So if we move upward in price, then we're going to move closer to the origin in terms of quantity. We're going to demand fewer units as a result. Once again, this is market demand. Just like in the supply case, there are a large number of demanders for this good, and their individual demand curves are summed up to get the market demand curve. I'm not going to go through that exercise again in this scenario because we did a very similar thing in the supply curve case. But you can do that just as well with demand curves. And so this gives us our demand curve. Let us do kind of like we did in the other case, and let's suppose that buyers are shifting away from bikes and towards scooters. So they demand fewer bikes at every price. So in that instance, let's kind of mark this out like we did before. And let's assume that at every price, they're willing to purchase 300 fewer bikes. So this becomes 700, this becomes 600, 500, 400, and so on. And finally at 2,300, no one's buying bikes. All right, so we can just as easily graph this as we did before. At a price of 200, they demand 700 bikes now. Right there. And let's do one at the other end. So at a price of 2,000, demanders only demand 100 bikes. So 100 puts us 2,000 right there. And this gives us our shifted demand curve. So demand has contracted as a result of this change in people's preferences. Just like in the case of supply, anytime the curve shifts, we call that a change in demand. So just to illustrate that, P, Q, downward sloping demand curve, and it shifts in either direction. That's a change in demand. If we move along the curve, then that's a change in quantity demand, or quantity demanded. So that's just another technical note to keep in mind. And just like supply, there are certain non-price determinants of demand. So for instance, buyers' tastes and preferences could change, like in the previous example I just mentioned. Buyers' income could also change. Prices of related goods and services could change. Expectations about the future, and number of buyers. So let's do a couple of examples of these just like we did in the previous one. Then let's say that buyer's income changes. So let's say that buyer's income increases. Then they're likely to want to purchase more bikes as a result. If we start with this demand curve, income increases, then we would see this demand curve shift outward as a result of the increase in income. So for another example here, let's think about buyers' expectations about the future. And let's say that they're really pessimistic about the future. Everyone's convinced that we're, beginning a recession, and we are likely to see falling incomes in the future. And so people may be less inclined to spend money under those circumstances. So let's draw that scenario out, Q and P. We got our downward sloping demand curve. And so if people are willing to just purchase fewer goods in general as a result of these kind of negative expectations about the future, then we would expect demand to contract as a result. With just like with supply, the D prime here representing the shifted curve after things changed. Think about for a moment how number of buyers would affect this diagram as well, just to kind of try that as an exercise. Let's return once more to our example of the market for lawn mowing services. So let's suppose that consumers' preferences change away from lawns. So suppose, for instance, there is a drought, and during this drought, many people's lawns die, and so they replace them with low moisture native plants or something. So if we've got this demand curve for lawn mowing services, essentially what this is fewer consumers are going to have lawns, and so the demand for lawn mowing services is likely to contract, right? So we can draw that here. And a lot of times with these supply and demand diagrams, we're not really trying to get exact numerical answers. We're just trying to get an idea for the logic and the tendencies of what's going on here. So a similar example here that would be something in the opposite direction is suppose that an office park with many, many acres of lawn opens up nearby, and then that would be an increase in demand for lawn mowing services, right? And so we'll see the supply curve or the demand curve shift outward instead. An important thing to keep in mind for demand curves is the idea of complements and substitutes. A complementary good is a good that's used with another good. In our first example, the bikes, a bike helmet is a good that complements a bike, so they're consumed together. And so if the price of complements increases, then quantity demanded of the good may decline even though its price has remained unchanged. So for instance, imagine that the price of bike helmets quadruples. That's part of the cost inherent in owning a bike, and so individuals will likely reduce their consumption of both bike helmets and bikes as a result of the change in the price of bike helmets. Substitutes are kind of the opposite. These are goods that can be used in place of another good. So if the price of a substitute declines, then quantity demanded of the good in question will also decline. And so a really simple example to think about this is like fast food, right? If the price of hamburgers falls, then you might be more likely to buy hamburgers instead of pizza. Or in the outset example here, we suppose that consumers are purchasing more scooters. Maybe that scooters over bikes, maybe that's because the price of scooters has declined. And so it's important to keep these complements and substitutes effects in mind for which direction a demand curve will shift. Something that we can think about here is like the prevalence of kind of smaller, lighter, more efficient laptops, like Chromebooks coming out, is a type of imperfect substitute for desktop computers or more powerful laptops, right? And so if the price of, say Chromebooks were to rapidly decrease, then people will be more likely to shift their consumption from traditional computers to Chromebooks, for instance. And so these are all another example of how complements and substitutes can play out in the real world. All right, so we've looked at the theory of supply and the theory of demand in isolation, but where the model really starts being kind of rich is when we put them both together on the same graph. So what we have here is the demand curve and the supply curve written where they overlap, and the same one for the market for bikes we've been using as an example along the way. And let's start by drawing the demand curve. So we take the first price, 500, and at a price of 500, quantity demanded is 900. At a price of 800, the quantity demanded is 800. Here. 1,100, it's 700. 600 for 1,400. And 500 for a price of 1,700. And so this gives us our downward sloping demand curve. So now let's draw the supply curve in blue. With our supply curve, at a price of 500, only 100 units are supplied. That's off the edge of the graph, so I'm not going to draw that here. But at a price of 800, the suppliers would supply 100 units, or 400 units. So let's just put that in somewhere right to the left of 500. At a price of 1,100, they supply 700 units. 1,400, they supply 1,000. It's right about there. And at a price of 1,700, 1,300 units are supplied, 1,300 bikes. And so this gives us our upward sloping supply curve. That point is a little bit off, but it should lie along the straight line. So this is our supply curve. Now you'll notice that they cross at some point, right? So they cross right here at quantity is equal to 700, price is equal to 1,100. And we can also see where that appears in our table, right there. We call this bundle of price and quantity where supply and demand are equal to each other, or quantity supplied and quantity demand are equal to each other, equilibrium. And so we say the equilibrium price is P star and the equilibrium quantity is Q star. And so in this scenario here, P star is equal to 1,100 and Q star is equal to 700. And so in equilibrium, the market clears. So that means that at the prevailing price, everyone who's willing to purchase a bike purchases one, and everyone willing to supply a bike supplies one at that price. The markets may tend towards equilibrium, but that's not to say that they will always remain in equilibrium. So they may end up outside of equilibrium in something called a surplus or a shortage. So in the event of a surplus, that means that the quantity supplied is greater than the quantity demanded. In a shortage, that means that quantity demanded is greater than quantity supplied. All right, so we can illustrate this idea of shortage or surplus graphically. So let's suppose that there's some price above equilibrium price here, and we'll call it pH. And if we follow this over, we'll see that corresponding to the supply curve, the quantity supplied is way out here, but the quantity demanded is way here. And so we can illustrate this idea of surplus, where quantity supplied is greater than quantity demanded, by this distance. So this is the surplus. And similarly, we can illustrate the idea of shortage. So switching or drawing another graph, upward sloping supply curve, downward sloping demand curve, and just like before, we've got some P star corresponding to equilibrium, and we could have some price below equilibrium that we'll call PL. And in this case, we see that the quantity demanded over here is greater than the quantity supplied over here. And so in this scenario, this distance here is shortage. And so if, for instance, we called this point point A and this point point B, the shortage would be given by B minus A. And so that's a simple illustration of those graphically. Let's think about shifting these curves around, because in general in questions in this class, we're trying to isolate things. So if I ever give you a question saying something happens, what's happening graphically here, only the supply curve or only the demand curve will move at once. I'm not going to ask you a question where they'll shift dynamically with both of them at the same time. So let's consider a different market here. Let's say there's a market for high quality basketballs. So let's draw our supply and our demand curve just like before, Q and P. So let's suppose that there is an increase in consumer incomes. So the first thing to think is, okay, which curve is this affecting? And since it's increasing consumer incomes, it's probably going to be something happening on the demand side, right? And then we need to think about which way it's going to shift. So if this is a market for high quality basketballs, we're assuming that as consumers increase their incomes, they're going to consume more of them, rather than, say, if it were like low-grade basketballs. So in this scenario, the demand curve is going to shift outward to D prime. Let's consider another example. So drawing up my graph just like before, demand, supply, Q, P. let's suppose that there is an increase in the wages paid to the workers who make these basketballs. So we've got an increase in costs of production. Think about which curve that's going to hit. So it's production, so it's probably going to be this. It's going to be the supply curve, right? And if the costs are increasing, that means it's more costly for producers to bring each individual unit for sale. So the supply is going to contract, so it's going to move towards the origin, giving us S prime here. We could create some other scenarios here. So let's think about just a change in preferences. What if the country suddenly becomes obsessed with soccer? Well, we're probably going to see people buy fewer basketballs. So this is happening on the demand side, right? So the demand curve will shift inwards towards the origin. So that's just kind of the broad class of questions that I'll ask a lot in this class is something happens, which curve shifts which direction? And it just takes a lot of practice. But another way that we can approach this is less with the table or graphically. We can approach this mathematically. So right here, I've got two equations that represent a demand curve and a supply curve, or the demand schedule and supply schedule that we've been working with in table form or graphical form. And so we can actually solve for equilibrium price and quantity algebraically using these equations. The first step here is to set these two equations equal to one another. So we know that equilibrium is where quantity demanded is equal to quantity supplied, so we can set QD equal to QS. And that leaves us with this expression, negative 1/3 P plus 200 is equal to 1/2 P minus 25. And so just like in your college algebra course, you need to get all the P's on one side and everything else on the other. So let's go ahead and move the negative 1/3 P over to the right-hand side. We'll have to create common denominators here. So let's call this 1/2 3/6 P minus 25 plus 200. And then this will be negative 2/6 P. So that we can easily add and subtract them. So we need to add 2/6 P to each side, which gives us 5/6 P on this side minus 25 plus 200. So now we can take the negative 25 over by adding 25 to both sides, leaving us with 225 is equal to 5/6 P. So now we just need to multiply both sides by 6/5, and that will leave us with P on this side and just a number on that side. So calculating that out is equal to 270. We can say then that P star is equal to 270. So this gives us P star, but we also need Q star, equilibrium quantity. And so the way that we do that is we take our P star value and we plug that into either our supply curve or our demand curve. It doesn't matter which. So let's go ahead and do that. So let's say Q, and we can drop the subscript here, is equal to 1/2 times 270 minus 25. So 1/2 of 270 is 135 minus 25. All of that's still equal to Q. 135 minus 25, it leaves us with Q is equal to 110. And there's our Q star. So in this market, with this supply curve and this demand curve, equilibrium price is 270 and equilibrium quantity is 110. So let's go ahead and do one more example like this before wrapping up. Here is a little bit more complicated version where we don't have specific numbers, but we've got these parameters, lowercase a, b, c, and D. Oh, this B should be a C. So just like before, we set these equal to one another. Negative AP plus B is equal to CP minus D. And just like before, we want to get all of the P's on one side. So let's go ahead and do that. So we've got B is equal to CP minus AP, and we'll go ahead and add the D over. So, and that A should be positive. So we can factor a P out of this. So we've got D plus B is equal to PC plus A. And then we divide both sides by C plus A, leaving us with P star is equal to D plus B over C plus A. And just like in the previous example, we arrive at Q star by plugging that back in. So if we've got this, let's plug it back into QD. So Q is equal to negative A times D plus B over C plus A plus B. So multiplying the negative A in, we get Q is equal to negative AD plus, let me make that D a little more prominent, negative AD plus negative AB over C plus A plus B. So now we can go ahead and put these over a common denominator. So Q is equal to negative AD plus negative AB. All of that is over C plus A. And this is equal to B times C plus A over C plus A. That's just multiplying by C plus A over C plus A, which is equal to 1. So this leaves us with Q is equal to negative AD plus negative AB plus, let's multiply that in, BC plus AB all over C plus A. So as we can see here, the AB's cancel out, and we're left with Q is equal to BC minus AD over, make that a little clearer, over C plus A. And this is our Q star. And so this would be, I wouldn't ask you to do one of these with just the parameters. I just wanted to demonstrate that you can do it without specific numbers. All right, so having gone through some of the basic examples of the supply and demand model, we should talk about some of the limits of the model. The simple supply and demand model is based on a number of simplifying assumptions, and the more reality strays from those assumptions, the less descriptive it's going to be. So some of the core assumptions, and this is not an exhaustive list, is that factors not relevant to price and quantity are unchanged. This is often abbreviated as other factors fixed, right? So we're assuming that nothing else is happening in the background that's going to alter supply or demand. We also need to assume that markets are competitive with perfect information. This is an important part of equilibrium theory. And so that's not to say that if we don't have perfect information or perfect competition, that the model is useless. Even if the assumptions are violated, a supply and demand model is a really useful starting point for our intuitions. It's just we need to be real honest about what's going on in this given market and if other factors are playing an important role in price and quantity formation. For instance, in highly concentrated labor markets where there isn't a great deal of competition, there is likely going to be a power imbalance between employers and workers, and that's going to be the overarching force that determines wage rate rather than pure equilibrium theory. But firms themselves are not charting supply and demand curves and setting their prices in that way. There are a number of different ways that prices are actually determined in the real world. There may be other institutions of custom or law that limits the adjustment towards equilibrium. I often cite minimum wage as part of this, but we also have customs and laws against like price gouging, like rapid increases in the prices of, say, generators when a hurricane is coming, right? And this is in part custom and in part law. Another example of a custom limiting adjustment towards equilibrium that I find kind of interesting is a lot of times gas stations in small rural towns will adjust their prices more slowly, because gas stations in cities are in competition with one another a lot more intensely. And so if the price of oil increases, they know that they're going to have to pay more to obtain gas in the future to sell to their customers. So they may increase their price currently, even though the amount they paid for the fuel that they're actually selling right now has not changed at all. While rural gas stations have kind of this closer knit community, and there's this idea of like, well, I'm not going to sell this to you for far more than what my costs are simply because the price of oil went up and I can. Another example of where the simple supply and demand model does not accurately describe price determination is instances of market pricing. And this tends to exist in scenarios where there is a lack of competition, where large, powerful producers will simply say, here are my costs, and now I'm going to put a premium of, say, 10% on top of it. In fact, the markup over cost is one way that we measure how competitive a firm is. Another way that maybe price determination strays from the model is loss leaders, or strategic pricing. And so my favorite example of this is the Costco hot dog. Every hot dog you buy at Costco actually loses Costco money. They sell it at a loss because they're pricing that strategically as a way to draw people in so that maybe they'll spend more money on laptops, televisions, clothes, whatever people are buying at Costco. And so there's a degree of kind of psychological trickery going on there. And finally, there's price discrimination. This is where a firm charges different consumers different prices. And this is rampant in the airline industry. Basically, the airline's able to gather a certain amount of information about the passenger and then is able to charge them a different price based on an expectation of what their highest willingness to pay is. And so all four of these scenarios are scenarios that are not really included in our basic supply and demand model. Some other kind of strange cases that are, or another strange case that is really interesting is that of a Veblen good. So a Veblen good has a demand curve that's got this kind of sideways U shape. They're also sometimes called positional goods. And so unlike a normal good, as the price of a Veblen good increases beyond a certain point, demand actually begins to increase for that good. And this is essentially driven by consumption for social status. So if the price of a certain, brand of car that is considered to be luxurious and a status symbol falls below a certain level, well, then normal people can buy it, and then its snob value is reduced. And so demand actually falls as its price falls. And so if suddenly, for instance, we could just manufacture large diamonds at incredibly cheap and accessible prices, then the snob value of diamonds declines. This is actually very interesting because we can manufacture diamonds, but there's still like some snob value attached to natural diamonds. But even that snob value is created artificially by the kind of diamond conglomerates that artificially hold down supply. But yeah, this is just kind of a strange and interesting case of us being able to see a deviation from our basic model, but being able to account for it by changing the shape of the demand curve. So, markets are a rationing mechanism. If we talk about, say, government rationing, it means that everyone must make do with less, or things are being distributed based upon need. But market rationing simply means that those that are unwilling or unable to pay will do with less. It's important to note that in some markets we may not care that much about equity. For instance, it may not be all that important that the supply of coffee is equally distributed among its consumers, or high-end cars or hot tubs, these kind of consumery luxury goods. But in other markets, we may care a whole lot about equity. For instance, markets for healthcare, housing, or wage determination in labor markets. So, using non-market forms of rationing is a matter of justice, social value, and efficiency. And all of these considerations, once again, lie outside of our highly simplified supply and demand diagram. The market value of a good, which I'm going to substitute with the letter M, is the maximum amount that economic actors are willing to and able to pay for a good or service. This is another way of describing it as effective demand. Social value is the extent to which an outcome moves us towards our final social goals, and these final goals are not going to be objective. So this idea of market value is kind of an individual concept, and social value is a collective concept. And so if the social value of the production of a good is greater than its market value, a market will under-provide that good. Classic example here, education. If the social value is less than the market value, then the market will overproduce the good. Once again, classic example, pollution, right? We're going to overproduce goods that, at least from a social perspective, we're going to overproduce goods that generate a great deal of pollution. And this relates to our earlier concepts of positive and negative externality. If the social value is greater than the market value, positive externality. Social value less than the market value, negative externality. It's also important to note that market equilibrium in no way suggests that human needs are actually met when the market is in equilibrium. Scarcity is ubiquitous, but the extent of this scarcity is often constructed by different powerful actors in the economy. So we need a different concept to deal with this rather than shortage and surplus, which has this market meaning that has little bearing upon actual human well-being. So we have this idea of inadequacy, which is a situation where there's not enough of a good or service provided at prices people can afford to meet the minimal requirements of human well-being. And so it's important to note that markets deal with scarcity, shortage and surplus, but they don't deal with inadequacy directly. They only deal with it indirectly through the way it deals with scarcity. All right. So, it's also important to note, just some closing thoughts I don't have on a slide here, is that the prices suggested by the models we're talking about are not necessarily going to be exact. What we have is a theoretical model that illustrates the concept, how suppliers and demanders behave. In empirical practice, equilibrium price may be different for each individual supplier in a market, or it may be some range with an error bound about it. So there's some degree of uncertainty about that. But just wrapping things up, supply and demand model is simple, but it's a powerful tool and often a good first pass model to apply to a market. When the real world deviates from the assumptions of the model largely, it makes it less descriptive. Markets may over or underproduce goods that generate externalities. And finally, markets deal with scarcity but not inadequacy, and so this leaves an opening for different forms of regulation and distribution that are non-market. I think that's all I got for this one.